All right, so let's review all the types of factoring that we have looked at so far. And in general, we've looked at 4 basic types. That's what we'll do in these notes, is review the factoring methods that we have learned so far in Unit 5. So first of all, we have GCF, pretty basic factoring method, just dividing out a GCF from all terms. And in general, you should always check for a GCF. In fact, sometimes some of these methods won't be available unless you take a GCF out first. So always check first thing if you can take out a GCF. It will always make it easier and sometimes make it possible to factor the other ways. Now grouping, you want to use grouping when you have 4 terms. And if it can be factored, it will always work out, but you need to have 4 terms. Now the AC method is when you are using a trinomial, typically in this structure, in this format, standard form, although sometimes those exponents can change. Sometimes it can be x to the 4th and then x squared and then c, and just depends on the trinomial, but in general you need to have a trinomial in this format. And then difference of squares, this is when you have a squared minus b squared. So a binomial, maybe I should add that, a binomial of form a squared minus b squared, and it will equal a plus b times a minus b. So as long as you have a difference of 2 squares, you can take the square root of both of those and then have a plus b and a minus b. And so those are the four different methods we have looked at so far: GCF, grouping, AC method, and difference of squares. And so what we'll do is just practice these. We'll do one of each, and then we'll look at one that combines most, if not all, of these. Okay, so first we have our GCF problem. Just a binomial here, 15x to the 4th y minus 12x squared y squared. So remember, look at the coefficient first. Between 15 and 12, we can take out a 3. And then for the variables, just if they both have x, it's in your GCF, and then put the smallest exponent present, so that's x squared. And for y, it's just a y. And now we need to divide this out. So it's not enough to just identify the GCF. We must also factor it out. So that means divide each term by that GCF. And so we have 5x squared minus 4y. And then that is all. Double check this binomial, but it is not a difference of 2 squares. So that is our answer there. For the grouping problem, you see we have 4 terms here. So let's look at the first 2. Well, first double check for a GCF. It actually looks like we can take out a GCF here of 2, but I believe that's it. So we can actually take out a 2, and that gives us 4x cubed plus 8x squared minus xy squared minus 2y squared. Not that that changed much, but it did make our numbers and our terms slightly easier to look at. So now from the first 2, we can take out a 4x squared, and that leaves x plus 2. And from our second 2, we can take out a negative y squared, and that also leaves us with x plus 2. So then we can get to our final answer here, 2, the 2 from the GCF at the beginning, the x plus 2 from our common binomials there, and then 4x squared minus y squared. And now I think perhaps unintentionally we have actually a difference of squares right here. I'm not sure in the creation of these notes I intended to have this whole thing happen. I think this was just meant to be a simple grouping problem, but that's okay. So we have a difference of squares right here. This is 4 is a perfect square, and x squared and y squared are both perfect squares. So we can go one step further, 2, and then x plus 2. The square root of 4x squared is 2x. The square root of y squared is y. So we have 2x plus y and 2x minus y. So earlier than we expected, we were able to have one problem combine almost all of our types, but that's okay. The main point of this problem was to illustrate grouping, which is right here, but it is always good practice to check for all the other methods as well. And so this one also had GCF and a difference of squares in it. All right, moving on. AC method. So remember, we have a trinomial. We multiply a times c, that's 24. And we're looking for two numbers that multiply to 24 and add to 10. 1 and 24 won't do it. 2 and 12 won't do it. 3 and 8 won't add to 10. We are getting closer. 4 and 6. 4 times 6 is 24. And 4 plus 6 is 10. So that works out. Split that middle term. 2x squared plus 4x plus 6x plus 12. And now we can factor by grouping. So the AC method always has grouping in it because of this middle step right here. We can take a 2x out, and that's x plus 2. And it looks like we can take out a 6, and then again x plus 2. It's nice that that always works out. So you know you're on the right track if these two things are the same. So we have our 2x plus 6 from our GCFs and x plus 2 from the binomials there. 2x plus 6 coming from right there. All right, that's the AC method. You know, quickly check. Actually, it looks like we could have taken a GCF of 2 out at the beginning, 2, 10, and 12. We didn't notice that, and that's okay. But if you look at this term right here, this 2x plus 6, we can actually take a GCF of 2 out right there. So we can do it at the end as well. So that's x plus 3, and then x plus 2. They can sneak up on you. So definitely, if you don't look for it at the beginning, it's okay. But you can always notice it at the end. If you have one of your factors with a GCF to take out, go ahead and do that if you see it. All right, let's look at difference of squares. One of my favorite ways to factor because it is the least amount to write down. Let's go ahead. So 81 is a perfect square. X to the fourth is a perfect square. 16 is a perfect square. And we have a difference here, a subtraction symbol, so we can do this pattern. So the square root of the first term is 9x squared. The square root of the second term is 4. And we want positive and negative here. And always double check this 9x squared minus 4. This is another difference of squares. Can't change the first one because it is a sum and we don't have any GCFs there, but we can keep going on the second one. So we get 3x plus 2 and 3x minus 2. Right, because the square root of 9x squared is 3x and the square root of 4 is 2. So there is our difference of squares, and I believe that is as far as we can factor. So always double check after the first round, double check for a second one. Okay, last one. Problem with a little bit of everything in it, which might have seemed challenging if we hadn't just done that on the grouping problem. So let's take a look at this one. 3x to the fifth plus 3x cubed minus 60x. Well, I can see right away they all have an x, and it looks like 3 is my GCF for that, so 3x I can take out. And that'll leave us with x to the fourth plus x squared minus 20. And I know we haven't seen many, if any, AC method problems with x to the fourth and x squared, but it will still work. So let's go ahead and do that. Two numbers that multiply to negative 20, that's AC, and add to positive 1. So I know my bigger number needs to be positive, my smaller number negative. So negative 1 and 20 won't cut it. negative 2 and 10, negative 4 and 5. There it is. That will add to positive 1. So let's split that middle term. X to the fourth minus 4x squared plus 5x squared minus 20. And now we can factor by grouping. So we can take out an x squared from the first set, and that leaves x squared minus 4. I think I can see where this is going. And then we can take a 5 out of the second set, and again, x squared minus 4. So let's write the answer we have so far. The 3x from the beginning, that's our GCF, times this x squared plus 5. I'll do that one first, because the second one I can see is a difference of squares, so I want to leave that one for the end just to make it easier to keep factoring. So I can split that last one up. So for my final answer, 3x times x squared plus 5, and then this is a difference of squares, so that's x plus 2 and x minus 2, right? Just take the square root of each term in that factor with plus and minus. Okay, so that problem had a little bit of everything, and actually was probably a little less challenging than the grouping problem, which ended up having just as much in it. So always double check after you get your first answer to see if there's anything else you can do. Check for a GCF, do that first. If you have 4 terms, look at difference of squares. If you have, grouping, not difference of squares. If you have 3 terms after you take your GCF out, check for the AC method. And then whether it's after your GCF or after your AC method, always check for a difference of squares at the end, just to be sure. It is a lot to remember, but as long as you keep in mind how each method works and think about when they work, go ahead and try your problems and see what you can do.